This next section is about heat and temperature. For this section, we're going to be using one main equation. That equation is Q equals M times C times delta T. Equation right here. Q is going to be your heat or energy. This will be referred to as joules or calories. Joules is going to be our capital J and calories will C-A-L. M will be our mass. This will not be molality because molality is an italicized M, and that is not what this is. This is a normal M, so this is just mass. C is called specific heat. Specific heat is going to be a constant that we're able to look up. This will be measured in joules, grams per Celsius, joules per gram per Celsius, and it is a material property, so therefore it is specific for each material that we're talking about. So it's the energy required to raise temperature 1 gram of substance by 1 degree Celsius. And there's a page in your book on page 508, but I've also scanned that into the next slide. Delta T simply means delta, again means change. Do not forget this. This will be how delta will be used almost always. So delta simply means change, and we're going to have the final minus the initial. So TF stands for the final temperature, and TI stands for the initial temperature. These will be in degrees Celsius. We don't have to do it in Kelvin because it would be the same change overall, and we usually use Celsius anyway, so that's what we're going to use. Here is the specific sheet chart that we're going to be using back and forth. So this right here will be, it says in joules times grams times Celsius, and this one is in calories grams per Celsius. It doesn't depend on what unit you're talking about. They're the same thing because joules and calories are just converted to different things. They've already done that for you depending on the unit you want to use. So here's a problem we have. We have 75 grams of water has an initial temperature of 19.8 grams and a final temperature of 26.7 grams. How much energy is added? The important thing here is we have water. It doesn't say ice, it says water. So we're going to use the liquid water here, which is 14.8, and we're going to go ahead and use the joules. So let's go back here. Let's go ahead and write down our equation. We're going to use Q equals MC delta T. So again, M is our mass. We're going to have 75.0 grams. We're going to have our specific heat, which if we go back, so I always forget what it is, it's going to be 4.18 joules per Celsius, or grams times degrees Celsius. And now we're going to multiply that by what our change in temperature is. And our change in temperature, maybe if our screen doesn't disappear, there it is. We're going to have to take our, again, so delta T equals TF, our final temperature, minus our TI, our initial temperature. So we know our final temperature was 26.7 degrees. We're going to minus 19.8. So we can't minus 7 from 8, so you're going to have to go up here, change this to a 5, change this to a 17, get 9, can't do this, comes a 1, 15, 6, so 6.9. And this will be left in degrees Celsius. So we look, our units can cancel. Our grams going to cancel, our degrees Celsius is going to cancel, we're left with joules. And Q, again, was our energy or our heat. So that works out perfect. So now we're going to type this in our calculator. We're going to do 75 times 4.18 times 6.9. And that is going to give us, if we look at sig figs, we have 1, 2, 3, 1, 2, 3, and then 1, 2. So we only need 2. But our answer is 2,163. So if we're going to go ahead and change sig figs, we would be left with 2,200 joules. And we usually report this in kilojoules, so we would have to just divide this by 1,000. So 1,000 joules for every 1 kilojoule. This is just the most common way energy is related, so that's why we're changing it to joules, kilojoules. So 2.2 kilojoules of energy. Excellent. That is all we have on heat and temperature. If you have any questions, ask me in class.